Love that. Okay. So what is churn analysis, everyone? Churn rate is a metric that describes the percentage of users who stop using a product or service within a specified time period, could be over annual or monthly or however. And churn rate formula is essentially calculated with the customers who left versus the customers at the beginning of the period and new customers during that period. So this is essentially the formula, and it's always expressed as a percentage. So yeah, so that is quite well used in product development, which is what I do, but also in marketing and finance and where else. So quite popular formula. Cool. So now the data set itself. There are a total of 23 columns, and I've broken them up into different categories. So we have, of course, the unique ID, which is 2 seconds. Okay, there is a total of 23 columns, of which there's a customer ID, demographic data, with which is gender, partner, dependence, which is a counter dependence, and senior citizen indicator. Then we also have product descriptors. So there's phone service, multiple lines, internet service, online security, which was also a type of service people could purchase, online backups, device protection, tech support, streaming TV services, and streaming movie services, all offered by this telecom communications company. And then the contractual type, of which there were 3 columns, being contract, paperless billing, and payment method. Finally, there was monthly charges as well as the total charges, which is basically the rolled up monthly charge. And then there was tech support, meaning the number of admin tickets versus the number of tech tickets. And then finally, there was a column called churn rate, where essentially it was a categorical data and it said yes or no. Okay, cool. And that is how the data set was structured. So just out of my head, I was thinking of what type of questions we can ask. And from where I was thinking about it, I was like, okay, so are certain product lines more susceptible to churning? What is the churn rate across the product lines? How does demographic positioning, for example, senior citizenship or gender, correlate with churn rates, if at all? Do certain product lines experience more tech support or admin support tickets than others? Is there a relationship between the churn rates and the amount of money charged to a client per month or in total? And what is customer lifetime value estimated per product line, and therefore what is cost of churn rate per product line? And how long does the average customer stay before churning? Now, I didn't do all of these questions. I did a couple of them. If you did anything else, or if you have anything else to show, you're more than welcome to just put up your hand or just drop your name in the comments so we can look at your work. But yeah. Or if you have an alternative way of looking at the data, you're more than welcome to raise that. But cool, let's go into the data. Let me just share the different things. And the nice thing about this is that this particular data set was stored on Kaggle, giving everyone the opportunity to start building their Kaggle profile at the same time. So, yeah. Okay. So, how did I go about doing this? So within Kaggle, just to explain what it is an open source data science community environment. And you can, instead of working on your Jupyter notebook or I actually want to use Jupyter right now, so I'm kind of floored. But instead of, or Google Colab or whatever else you use to write your code in, you can use their notebooks that are hosted on their platform, and everything runs within them. So yeah. Okay, so like with all things, you import the various modules you require as well as importing the file. And this is essentially what the data set looks like. There's not an enormous amount of cleaning required within this data set. Sorry, folks. Within this data set, it is very well cleaned, which is kind of why I chose it. And then here we go. So I thought I would have to clean the total charges data when I was doing a bunch of research on this data set, and it didn't seem that I actually had to. There were a lot of, I thought that there would be a lot of data points where there were spaces at the end, but I couldn't find any. Yeah. So moving right in to first the analysis, what is the current churn rate across all product lines? I just wanted to first show a pie chart showing the proportion of users who churn. And this is where we got as a very first initial graph. I know it doesn't look too great, but there were 26.54% of current customers who do churn. And it was difficult to understand the relevancy of that number, so I had to go do a bunch of further research for the telecommunications industry, and that seems to be roughly in line with their benchmarks. However, I was looking for US data, and that's there. I don't know if that's still relevant for South Africa. Yeah. And then churn rate per product line. So within product lines, I only looked at the internet service product line and churn, but I think something that could have taken the data analysis further would have been merging all of the product lines into one particular column. I was just a bit uncertain of how to do that without messing up the data. So for here, so we basically looked at it and I just put in a little formula of number of churn customers divided by total number of customers. So we come out with this little item here. So 18% of customers who churn for DSL, 41% for fiber optic. And then if you don't have purchased any internet service from this telecommunications company, you typically only churn 7.4% of the time. So I thought that was super interesting. I was really curious about why the fiber was problematic. And then we have this little graph to visualize that. Okay. And that's just created a normal way via matplotlib. Okay, and then how does demographic data, so age and partner status, correlate with churn rate, if at all? Cool. So then I just asked a bunch of questions underneath that. I looked at monetary value. What is the total amount charged per month for each product line? How many customers are subscribed per product line? And how much money has been lost by clients churning per month? So the total amount charged per month for each product line, of which the ones I was really looking at. So we have DSL, fiber optic, and neither. And this is all in US dollars, but I think it's $5,121,885 per month for DSL. And there's $9,923,081 for fiber optic. And then just over $1 million for neither of those options. And you get a similar graph out here. Cool. And then we look at the number of customers who are subscribed by product line. And you'll be noticing that the main function I've been using so far is group by and dot size. So it's nothing too complicated. Yeah. And then we're still looking at that and we see how that is basically the customer split and with the vast majority of customers being on fiber. Cool. And then we look at churn customers and calculate the total monthly amount lost to churn, which works out to roughly just over $2 million, which was quite substantial in my mind. And then I also, as a last thing, I was looking at the correlation between senior citizen or gender columns with churn rate. And I had to do some research on how to do this, but from scipy.stats, the module, you import the Pearson R and point by serial R, and I'll explain what those two different formulas are. And essentially, the first thing you have to do is senior citizen is in a weird, I think it says yes or no, and then you have to put it as type category, or it was 0 or 1, yeah. And then you have to map it. And then for gender, you also have to map female and male to either being 0 or 1. And the same with like churn rate. And then you just like apply the formula, which was either Pearson R or point by serial R, and then you get out the correlation. So correlation coefficients operate on a scale with -1 being a strong negative, 0 being neutral or it does not apply, and positive one meaning it's strong positive. So gender had negative 0.01, so very low correlation. And then senior citizen had a 0.15 correlation, which could be rounded up to 0.2, but even still, it was quite, it was still not significant enough to explain the rate of churn. Okay, and then this just explains the two. So Pearson correlation is almost a standard one we use in that it is both continuous data types and it specifically deals with variables that have a linear relationship. And then a point by zero correlation is something that looks at a binary variable, so yes or no data, and compares it with continuous data. And then the last thing I was just doing while waiting for this was tech support tickets per product line. So also just a group by and a filter, essentially to explore how many tickets were created per product line. Yeah, some things that I've been thinking about that could have made the data analysis stronger was just further exploration of the correlation rates, as well as that combination of all of the product lines into one. But I'm always open to hearing more feedback. Yeah. Does anyone would like to ask questions or would they like to show their own work now? Or not, just ask questions? Or give feedback? No? Oh, okay, well, that's cool. So the last thing, if we don't have anyone else to show or you have no questions, is I created a little simple poll to hear what all the data-minded people would like for their next hackathon project. I'm gonna post it in the chat if you guys wouldn't mind voting. Where's the little chat? Chat. So, but yeah, any feedback on the analysis or if you guys had any questions about the data?
There, can you hear me?
Yeah.
Yes, I just wanted to ask a bit more about the data. Where's the data from and what company is it? I didn't get the full context. Came in a bit late.
Okay, cool. So the data, it comes from a telecommunications company. Unfortunately, it was anonymized and posted online onto Kaggle. So we know it's an American company, but it's unclear which one it is. Yeah, so, and then with the actual data set itself, it had about 23 columns and they were split amongst demographic data being like your senior citizenship status, gender, the amount of years you've been with the company, and then like the product specific thing, as in which products the customers subscribe to, the amount of money they were charged for those products, as well as whether or not they had churned. So that was essentially how it was split. So this was very much a visualization style data set. Yeah. Although I'd seen some people try to do statistical predictions on the data.
Oh, okay. And then I was curious, perhaps before this or another time, did you ever explore, let's say, if there are price changes and what the customers were being charged and or anything of that nature?
Unfortunately, it only showed me the data set. It only shows the price at a point in time, and it didn't show price. It wasn't like over months or years, so it wasn't possible to compare if price change was the reason. That was something I was quite interested as well. Yeah.
Okay. So they didn't give you like at least price over time, let's say per customer or anything like that, or anything to that detail.
Yeah. So
Okay.
unfortunately, that means that like because it wasn't historical, there wasn't we weren't able to track the customer over time. Yeah. So yeah.
Okay. Yeah, okay. No, I thought yeah, I think yeah, okay. I would have assumed they would have given at least historical data, at least that would have made the analysis a lot more powerful. Or at least yeah, much more easier to determine what is going wrong. But okay, cool. Thanks so much.
Cool. Thank you. Carlo, I see your image. Can I show it on the screen just so everyone can look at it? Is that okay? Cool. You want to just talk about it? It looks very cool. It seems to be a heat map showing correlation between the various variables. Is that a correct understanding?
Hi everyone. Celestine, yeah, that's exactly it. It's just a heat map looking for correlation. But yeah, I wasn't really able to find much. It's the same picture, just with different colors, facing different directions. But yeah, I mean, I was looking for patterns, didn't really find any. But I like the way that you did it. You investigated each variable quite nicely. I'm definitely going to take that to my job more. So thank you for presenting.
Okay, awesome. Awesome. That's really cool. And I like the way that it just shows like the different strengths. Like I wouldn't have thought, yeah, it's really cool actually. I often forget about heat maps, but they are a great tool. Yeah, this is really cool. So I also like to see how they line up. And it's cool that somebody else did a Pearson correlation because I forgot about my like velocity statistics until preparing for this. So that was quite cool. Yeah, that's really awesome. Thank you, Carlo. Cool. Yeah, so that is everything from my side. Is there any more questions or comments? Otherwise,
I just have a question. I'm fairly new to data analysis. I'm actually still just studying on Coursera now. But one thing I was wondering that I just thought would be interesting would be looking at the tech tickets to the churn rate, and if anybody did that, like how many tech tickets were there connected to when there was a churn?
that is a really great question. I saw someone doing that on Kaggle, and maybe I can just post that for you in the group chat. But it wasn't something I specifically looked at, but it is very similar to what I did where I did the correlation check for the gender or senior citizenship. You would also be performing a correlation analysis between tech tickets and product lines, or tech tickets and churn rates for those product lines, just to go and see how they match up. Yeah, that is an interesting point. Yeah, and I imagine it is very impactful given customer service. But yeah, it's quite cool. Yeah, and I can see the votes have been coming through, so thank you so much for that. I appreciate it. Cool. Yeah, and then that's about it. In terms of like data analysis and like learning for it, I always recommend Coursera or DataCamp. But yeah, I wish you all the best, Sherilyn. It's quite cool. Yeah. Okay, guys. Well, this has been a really interesting discussion tonight, and I really appreciate it. And thank you so much, Carlo, for showing me your heat map. I really, really enjoyed that. And I wish you all a super awesome evening. Have a fabulous day, and I hope to see you all at the next Data Dragons hackathon. Cool. Thanks, guys. Ciao, ciao.
All right, cheers, cheers. Thank you.